Welcome to Electrical Engineering Technology. So friends, today in this particular session we are going to learn how the superposition theorem can be verified through the virtual mode of experiment. Okay, so we'll try to learn with the help of virtual mode. So here we'll try to understand how this particular superposition theorem can be performed. So here we have the procedure, okay, and this is the circuit diagram where we have there are three resistances and these are the two sources. Okay, apart from this, we have the simulation process, that is, it is simulated in three cases, that is case 1, case 2 and case 3, so which we will discuss in the procedure. Okay, so once we calculate once we perform the case 1, case 2, case 3, after that we have here observation table. Okay, you can see the observation table. In the observation table there are total 5 observations have been taken. We can take total 5 observations. You can take more than that or less than that. In this you will have the this is in presence of both the voltages, okay, and this is in presence of V1 only, and this is in presence of V2 only. Okay, likewise we get all the readings. Okay, so we'll try to understand the procedure basically, and then we'll try to perform this particular superposition theorem experiment. Set all the resistances R1, R2, R3, okay, and choose any arbitrary values of V1 and V2. So you can see in this particular diagram, okay, so this is a resistance, and this is the second resistance, and this is the third resistance, which are connected in the circuit. Okay, and so what we need to do first, we need to set the resistance values. So initially we have taken, this is 200 ohm resistance, and this resistance is 300 ohm, and this is the 500 ohm resistance. Okay, so any arbitrary values, and we need to select the values of V1 and V2. So this is the V1 and this is the V2. Okay, so V1 has provided 220 volt, okay, and V2 has provided 110 volt, because it has given the maximum capacity of this particular V2, and this is for V1, that is 220 volt. Okay, apart from this, you just try to understand here there are 3 ammeters have been connected to get the branch currents of all these branch. Okay, and here S1 is DP DT switch, S2 is also DP DT switch, that is double pole double throw switch. So in this, when you see here, there are options are there. When you put it in power, so it will provide the power supply, that is 220 DC voltage to the circuit. At the same time, when you provide short circuit, then it will be short circuited like this. It will shift towards the B, that is it will be shorted like this. Okay, the same thing will be applies at this switch 2. So you can see power and the short. So based on our procedure, we will try to utilize these things. Okay. So initially what we done, we done the resistance values have been set, okay, with the help of this you can take the help of the keyboard as well, and you can vary your resistance values, and even you can vary the voltages, that is you can take it as V1 and this V2. So thus this portion have been completed. Now to perform this, we need to go through these three different cases. In the case 1, according to the superposition theorem, okay. So case 1, in presence of both the sources, okay, we'll try to find out what is the current by using these two sources, that is source 1 and this is source 2, and we'll try to find out what is I1, I2 and this the I3. To do this, case 1, select the switch S1 and S2 to power, okay, and simulate the program. Observe the result from the case 1 table. So therefore, for both this V1 and V2 have been provided with a power, okay. So this is a power and this is also power, because in the case 1, in presence of both the sources. Then so already we have taken the resistance values, okay, and the voltage sources, and here we will come here and click on this case 1, okay, click on the case 1, and then see determination of branch currents in presence of both the sources, okay. Select both the switches S1 S2 to power, we done it, and then click on the simulate. So if you click on this particular simulate, so all the branch currents reading, that is ammeter current A1, ammeter current A2, ammeter current A3, that is all the branch currents will be calculated by itself virtually, okay. So we'll try to get that. See, so the branch current 1, that is ammeter current A1 is 0.39032, okay, and ammeter 2 will be minus 0.10645. A3 is 0.28387. So you can see here also it has shown the same values which is calculated in the case 1, okay. So you can see the same values have been calculated and shown here, and you can see how clarity it will give you, okay. So it is a positive value, you can see in the ammeter. So if you come from here to here, okay, left side, it will be a minus value and it will be plus value. So the value is plus, so it has been tilted little bit towards the positive. And then here also you can see it is the minus value, the ammeter current 2 is minus value, so therefore it is tilted towards minus little bit at the same time. So this is the positive value, A3 is positive, so therefore it tilted towards the positive side, okay. Likewise, so you got all the three branch currents through this, okay. And then we need to go for case 2. In the case 2, in presence of V1 only, that is in presence of this particular V1 source of supply to the circuit, and then what we need to do here, you can just see apply the switch S1 to power. So this S1 has to be provided with the power, and short the S2, so this S2 has to be shorted, and we need to do the simulation. Okay, so what we'll do, we'll take it as a short circuit. Okay, thereby there is no source of voltage at this S2. Okay, so only by considering this S1 we are performing. Now we'll go with this calculation of currents. So click on case 2 because we are performing on the case 2. So then again the same thing you need to do. I will go with the simulate. So I will click on simulate. So the values we got same thing, and you can able to observe all the readings which are calculated through the simulation. And then the case 3 is in presence of V2 only. So here we will try to provide only V2 and V1 is to be shorted. Then we need to go to the case 3 and calculate by virtually all the 3 branch currents. Okay, so I will go with the simulate, and then it is calculated, and same thing has been shown on this particular diagram. Okay, and then so the final thing is that, so we calculated by using all the 3 cases, by considering 2 sources, by considering 1 source, that is V1, by considering second source, that is V2, and finally, so this is in presence of both voltage, this is in presence of V1 and this is in presence of V2. So thereby, if I click on this fill data to the table, so then all the values which is calculated will be pasted in this particular observation table. So it is telling that the observation table is updated, change the resistance and voltage source value to take another observation. So say OK. So it will be pasting all the values which is calculated through the virtual. So you can perform other values as well by changing the resistance values and by changing the voltage sources, and you just follow all these 3 steps or 3 cases to verify the superposition theorem. Thank you very much.